Use a ruler to draw the reflection of this shape in the mirror line. So we have a diagonal mirror line, but to make it easier for ourselves, what we can do is just turn our page so that we're looking at the mirror line vertically. Then what we need to do is to dot our corners before joining them up. So this point here is on the mirror line, so it will be on the mirror line when we reflect the shape. This point here is one dot to the left, so we go one dot to the right, and then this point here is two dots to the left, so we can dot two dots to the right, and then we have another point that's on the mirror line. So now we just join up our points and we have our reflection. Draw two more circles on this grid to make a design that has a line of symmetry. So a line of symmetry is a mirror line. That's where you can draw a line down the middle and have the same reflected on both sides. So if we draw a horizontal mirror line or line of symmetry, then we can see that we need to draw a circle in this square here and in this square here, so that we have the same reflected on both sides. Or there is another possibility. We could have a diagonal line of symmetry, so then we would need to draw a circle in this square here and in this square here, so that our circles are the same distance from the mirror line or from the line of symmetry on both sides. Tick the correct phrase to complete the sentence. A number that is not prime is called a prime factor, square number, composite number, or common factor. So remember, a prime number is a number with only two factors. It's a number that's only in the 1 times table and its own times table. And any number that is not prime is called a composite number. So most numbers are composite numbers. A shop sells notebooks and pens. Hassan bought a notebook and a pen. He paid £1.10. Kate bought a notebook and 2 pens. She paid £1.45. Calculate the cost of a notebook. So Hassan bought a notebook and a pen, and that was £1.10 altogether. Kate bought a notebook and 2 pens, and she paid £1.45. So first, let's find out how much more Kate paid than Hassan. If we subtract £1.10 from £1.45, that gives us a difference of 35 pence. And for that extra 35 pence, Kate got 1 extra pen. So we know that the pens cost 35 pence. And knowing that means that we can calculate the cost of a notebook. If we look, Hassan spent £1.10. He got 1 pen, but if we subtract the cost of a pen, so subtract 35 pence from £1.10, that gives us 75 pence. So we know that notebooks must cost 75 pence each. So notice here, the only way that we could calculate the cost of a notebook was finding the cost of a pen first, because if we look what was different about what Hassan and Kate bought, it was just that Kate bought an extra pen. So knowing that meant that we could work out how much a pen cost by working out how much more Kate paid. And then once we'd worked out the cost of a pen, we could subtract that from the total, and that would give us the cost of a notebook. This is an open top box. Put a tick for each diagram if it is the net for the box. Put a cross if it is not. The base is shaded in each one. So if we look at this diagram, the shaded squares will be our base. These 2 squares will fold up. These 2 squares here will fold up. And then when these squares have folded up, this square will fold round and cover this edge, and then this square here will be able to fold round and cover this edge. So we can make an open top box. But if we look at this diagram, we can see that this square here will fold up, and when this square has folded up, this square will be able to fold around and cover this edge. This square will fold up, this square will fold up, but when this square folds up, this square here will fold over the top, and we want an open top box. The other problem here is that this edge won't have anything covering it, so this diagram is not the net for an open top box. Now if we look at C, we have our base. This square will fold up, this square will fold up, and then the squares at the sides will be able to fold around and cover all of our edges. So we have an open top box. And here we can see our base. We can see that these two squares will fold up, the bottom square will fold up, these two squares will fold up, and then this square here will be able to fold around and cover this edge as well. So again, we have the net for an open top box. Write the 3 missing digits to make this subtraction correct. So we have a missing digit subtraction problem, and we can solve this by following the same steps that we use for column subtraction. So that's working from right to left. So here, starting with our ones column, we have 2 minus something is 7. But clearly they haven't subtracted from 2 to make 7. They must have exchanged and subtracted from 12. And because they exchanged, we need to exchange as well. So we go to the left, 1 less, 1 in front, and now 12 minus 5 is 7, because 12 minus 7 is 5. So we can move on to our tens column. We have 3 minus 6, and we have 7 as our answer. Again, they haven't subtracted 6 from 3, they must have exchanged first. We don't know the digit that they exchanged with, but we do know that after we exchange, we can put 1 in front, and 13 minus 6 is 7. So now we have something minus 3 is 4. Now 7 minus 3 is 4 because 4 plus 3 is 7. So after they'd exchanged, they would have had 7 as the hundreds digit. And because they exchanged, this number or this digit here must have originally been an 8. Because remember, when we exchange, we have 1 less 1 in front. So this digit here is an 8. Then we have 7 minus something is 5. So that's 2. And then 9 minus 1 is 8. So we have our missing digits. And then what we can do to check is just to write out what we have and check that it works. And when we do the column subtraction again, we can see that we get the same answer. Match each fraction to the percentage which has the same value. One has been done for you. So we need to remember that a percentage is a fraction which has a denominator, a bottom number of 100. So 1/2 is the same as 50% because 1/2 is equivalent to 50 hundredths. Now we need to match 3/4, so we can find an equivalent fraction for 3/4 which has a denominator of 100. 4 times 25 is 100, and what we do to the denominator, we do to the numerator as well, and 3 times 25 is 75. So because 3/4 is equivalent to 75 hundredths, that's equivalent to 75%. Now we have 1/10. We can find an equivalent fraction with a denominator of 100. 10 times 10 is 100, 1 times 10 is 10, so 1/10 is the same as 10% because it's equivalent to 10 hundredths. And now we have 10/10. That's the same as 1 whole because 10/10 is equivalent to 100 hundredths, so that's 100%. Here is a regular octagon. calculate the sizes of angles A and B. So we know that an octagon is an 8-sided shape, and the word regular is important here because that tells us that all of the sides of the octagon will be the same length, but it also tells us that the angles will be the same size because angles in a regular shape are the same size. So if this angle here is 135 degrees, all of our other angles will be 135 degrees as well. Now another fact that will be useful here is that angles on a straight line add up to 180 degrees, and we can see that we have a straight line here. So to work out angle B, we can subtract 135 from 180, and that gives us 45 degrees for angle B. Now to calculate angle A, we might spot that we have another straight line here. Now we know that one of the angles on the straight line is 45, so to calculate the other angle, to calculate angle A, we can subtract the angle that we have, so subtract 45 from 180, because angles on a straight line add up to 180 degrees. And this is still a straight line, even though it's not horizontal. So angle A is 135 degrees. There are other ways of working out this question. So we might spot that this line and this line are parallel, and these lines are parallel as well. And angles on parallel lines will always be the same size. So because this is 135, we know that angle A must be 135 as well. Or we could use vertically opposite angles. So when we have straight lines that cross, the angles on opposite sides are always the same size. So because we know that this angle here is 135, we know that angle A must be the same because it's opposite. Write the missing numbers in the sequence. We have 273,001, 283,001, 293,001. So if we highlight the digits that have changed, it's the 10,000 and 100,000s digits. So we have 27, 28, 29. So the next number in the sequence will be 303,001, because we can see the 3001 always stays the same, and then if we look at our 100,000s digit and 10,000s digit together, we have 27, 28, 29, 30. So here we're adding 10,000 each time. So now we need to find the number in the sequence that's before 273,001. That must be 263,001, because the 3001 always stays the same, and then the number before 27 is 26. Circle two fractions that are equivalent to 0.6. So remember, with decimals, the first digit after the decimal point tells us how many tenths we have. So 0.6 means that we have 6 tenths. But the question says circle two fractions. So the other one must be 60 hundredths, because remember, with decimals, we can write zeros on the end without changing the value of the number. And the second digit after the decimal point is the hundredths digit. So if we have 0.60, we have 60 hundredths. And the reason why we can write zeros on the end of decimals without changing their value is because that's just an equivalent fraction. So 6 tenths is equivalent to 60 hundredths, because 10 times 10 is 100 and 6 times 10 is 60. So 6/10 and 60/100 are both the same value as 0.6.